Hi, today I will be talking about 4 different factors that you should take into account when you are comparing the acidity or basicity of a molecule. So the first one is the atom. And so when you're comparing two atoms that are in the same row, you want to take into account the electronegativity. And the electronegativity increases as you go from carbon to nitrogen to oxygen to fluorine. That's because fluorine is the most electronegative atom because it holds on to those electrons very tightly. And so if you're comparing atoms within the same group, you will take into account the size of the atom, because the iodide is one of the strongest acids, and that is because of the size. It can hold the minus charge very well around it, because of how big it is. The second factor that you want to take into account is the resonance. In this resonance example, if you were to deprotonate the H of both these molecules, you would have nothing to resonate this negative charge with. While on the example on the right, you can have resonance within the molecule itself, forming a molecule that looks like this, O minus, and then a double bond O. And because of resonance, this molecule on the right is more acidic because the conjugate base is more stable. And if the conjugate base is more stable, that is a sign of increase in acidity. The next factor that we want to take into account is induction. And induction is essentially the pull of an atom that influences another part of the molecule. So in this example, fluorine is pulling charge from this OH. So when this H gets deprotonated, this minus charge gets slightly pulled to the right because of induction. However, the trend for induction is the opposite of that of the atom, because fluorine is the most electronegative, and then it goes chlorine and bromine and iodine. So as you go up the periodic table, that increases the electronegativity. So this molecule would be a more acidic molecule than the one on the right. The last factor is hybridization. And so hybridization takes into account the amount of S character. So in this molecule, the hybridization is sp3 for this. Number 1, 2, 3, 4. Same for 2 and 3, 2 and 3. So the S character here is 25%, because 1 out of 4 is 25%, while the middle one has an S character, has a hybridization of sp2, and so this is equivalent to 33%, or 1 out of 3, because there's one S and a total of 3 S, P, and P. And finally, this molecule on the right has an S character, has a hybridization of sp, essentially saying that it has 50% S and is 1 out of 2. And so the more S character you have, the more acidic you are, because you can hold the negative charge closer, therefore stabilizing.